We're about to take a look at this really fascinating glitch in your brain. It's like a hidden battle that's happening all the time. But, to really get it, you've got to experience it for yourself.
So get ready, I'm about to show you two sets of words. The job is simple, but here's the catch. Speed is everything. You have to do this as fast as you possibly can.
Okay, you ready? Your task is to say the color that each word is printed in out loud. Not the word itself, just the color. Do it for both sets. Go. So, how'd that feel? If you're like most people, that bottom list was a total breeze, but that top one, yeah, probably not so much, right? You might have found yourself slowing way down, maybe getting a little tongue-tied, or even making a mistake. That little mental stumble you just felt, that is exactly what we're here to talk about.
So what was that all about? You just experienced one of the most famous, most studied effects in all of psychology.
It's called the Stroop Effect. It's that delay, that mental traffic jam that happens when the words you're reading and the color of the ink don't match up. The word red, printed in blue ink, creates this little conflict in your brain. And believe it or not, resolving that conflict takes a measurable amount of extra time. Now, while John Ridley Stroop is the one who gets the credit, he's the one who really popularized it with his paper in 1935, the effect was actually first described a few years earlier in Germany. But it was Stroop's work that totally cemented its place in history, leading to, an incredible amount of research that continues to this day.
And this right here shows you his original really elegant experiment. He had people do two simple things. First, just name the color of some solid squares. Easy. Then he had them name the ink color of words that spelled out a different color. And the results, well, they speak for themselves. That first bell curve shows the time it took to name the colors of the squares. Fast, no problem. The second curve, you can see it shifted way over to the right. That's the time for the conflicting words. That big gap right in between them, that right there is the Stroop effect. Visualized.
Okay, but this brings us to the big question. Why? Why is this so hard? Why can't our brains just, ignore the word and just focus on the color?
Stroop himself totally nailed the core reason way back in his original paper. Our brains are just wired to read. It's automatic. We see a word and we process what it means without even trying. So to name the color, you have to actively fight that powerful automatic impulse to just read the word. A really good way to think about this is like there are two competing processes happening. Reading is an automatic process. It's like trying not to read a giant billboard as you drive by. It's pretty much impossible, right? But naming colors, that's a controlled process. It requires deliberate focus and attention. So when these two are in conflict, the automatic process of reading almost always wins the initial race. So over the years, scientists came up with several theories to explain this, and they're often called race models. Just imagine the two pieces of information, the meaning of the word and the color of the ink, are in a race to your brain's decision center. Well, the word's meaning gets this massive head start every single time. It doesn't matter if it's because reading is just faster or more automatic or because it uses a more well-worn neural pathway, the result is always the same. The wrong information gets there first, and that's what causes the interference.
Okay, so we know what happens, and we've got some pretty good theories about why. But now, with modern technology, we can actually see where this battle is taking place inside our heads.
Using modern imaging like fMRI, scientists can literally watch the brain as it deals with this conflict. And they've pinpointed this one key region, the anterior cingulate cortex, or the ACC. The best way to think of it is as your brain's internal alarm system. During the Stroop test, this area just lights up like a Christmas tree as it basically shouts, "Whoa, hang on, something's not right here."
But the ACC doesn't work alone. It's part of an executive team. So after it sounds the alarm, another part of the brain steps in to manage the task. This area sets the goal.
Okay, new rule, ignore the word, focus on the color. The ACC then acts as the monitor, flagging any conflict to help you stick to that rule, even when that automatic urge to read is just screaming at you.
So this simple but really powerful effect, it's not just some fun party trick. It's actually been adapted into one of the most versatile tools in neuropsychology.
Because it's such a fantastic measure of our executive functions, things like attention and cognitive flexibility, clinicians use the Stroop test to help assess a huge range of conditions. A significantly slower response time, for example, could provide really valuable clues about brain health, everything from the cognitive impact of a concussion to the attention challenges that come with ADHD.
And this core idea of mental conflict is so solid, so robust, that researchers have come up with all sorts of clever ways to adapt it. They've created a bunch of variations of the Stroop test to explore all the other hidden battles that might be happening inside our minds. For instance, there's something called the emotional Stroop effect. People are actually slower to name the color of emotionally charged words like pain or grief compared to a neutral word like clock. It shows that our brains automatically process the emotional weight of a word, and that emotional response gets in the way of the simple cognitive task. It's a really powerful tool for studying conditions like depression and anxiety.
And then there's the numerical Stroop effect. Here, the conflict is between a number's value and its physical size. It's actually harder to tell that the number 5 is bigger than 3 when the 5 is printed smaller on the screen. This just goes to show that, just like reading words, our brain's interpretation of quantity is also a really powerful automatic process that can interfere with other things we're trying to do.
The effect has even broken through into pop culture. It's been turned into a game in Nintendo's Brain Age, used as a challenge in horror games, and even popped up on TV shows like Mythbusters and Nova to test how things like distraction or even high altitude affect our mental sharpness.
So when you really strip it all down, the Stroop effect is so much more than just a brain teaser. It's a perfect little window into the constant, invisible effort our brains are making to control our own behavior. It reveals our ability to consciously override a powerful, automatic impulse to achieve a specific goal.
And that kind of leaves us with a final thought, doesn't it? The battle between automatic reading and controlled color naming is just one example. What other deeply ingrained habits or assumptions or biases are running on autopilot in your brain, shaping your perceptions and your decisions every single day? It's something to think about.